Hello class, this is Mr. Miller, and I wanted to go over the Phase Change Lab 2.06 with you. We were having a lot of problems with this lab, so I figured I'd establish a recording and put it in a recording folder in the class agenda in order for you to refer to get the best grade that you can. Now, I have the text for this lab in this recording, but before that text, I also included a rubric for the lab. A rubric is, for any assignment, a list of expectations for that particular assignment. I include rubrics in all the labs that I hand back to you. I also highlight the questions that if you turn in a lab and you miss, say, on number 2, you miss a point, I highlight that, and sometimes I'll even add more notation just to give you a better idea of what you need to do to get a better grade for that particular number, and obviously for the lab also. So that's what a rubric is, and here's a rubric for this lab. It is worth 27 points total. The overview of this lab is this. A phase change is when a substance changes from one state of matter to another. In this lab, you will see how its temperature is affected by phase change. You'll watch a video of ice being heated to steam. Data from this video lab is provided to you along with a graph. Then you will determine how energy added to the system is used at different points in the process. Now, the first step is this. Read the 2.06 lab. Make sure you do that. Also, make sure that you read all the lessons up until this lesson 2.06. The link for this lab video is contained underneath the step 1 statement. And then we get into the questions. The first question is, write the goal of the lab, or the question being answered. Hint is to look at the question in the mastery map on the first page of lesson 2.06. If you would log on and access that mastery map, this is what you would see. Now right here is the question. How are phase change and temperature related? That is what you need to put in your answer box to get full credit. Number 2 says, what personal experiences have you had with working or watching a substance change from one phase to another? And I know you've seen a bunch of different phase change, usually with water, from whether it be solid water to liquid or liquid water to gas. So there you've got some points that you could use just to let me know what your personal experiences are with watching or observing phase change. It doesn't have to be detailed, and I'm going to be a little bit easier on this particular question because this lab's a little bit more difficult. We're asking how temperature and phase change are related, and a lot of times we just watch the phase change. We don't really take the temperature, so I'm not going to hold you to that in this particular question. But I do want an experience that you've been able to at least see a phase change. I want the change of phase from one phase to another, and I want you to let me know circumstances, like was it wintertime or was it in the middle of summer, or exactly what you saw, maybe some extra little notes if you saw something particular that you made a mental note of, even though you may not have been scientifically thinking. That's exactly what you're doing. Number 3, state your hypothesis. Fill in this blank. Now, we have a great hint right here. This question, this hypothesis must be in if-then form. I don't accept anything else. The hypotheses are always in if-then form. If the ice is melting, and in parentheses, or vaporizing, then the temperature will what? Will it increase? Will it decrease? Or will it stay the same? Now we're talking about melting or vaporizing. So those are two vastly different temperatures. And one of these answers fits in this hypothesis. What does it do? Does it increase, decrease, or stay the same? One of those 3 answers in this box will get you credit. It doesn't really matter which one either, because the hypothesis is a guess. It's an educated guess, but it is a guess. And even if you're wrong, you can get credit for this if in the conclusion, when you start writing about what happened in the lab and what you actually observed and what the evidence points to, if you include in that conclusion, hey, my hypothesis was way off. I said it was going to do this, and it didn't. It did this. And this is why I think it did this, then you'll get full credit. Step 2 is watching the video. So make sure you watch this video and make sure that you study this table. Look at the table. This is a time table versus a temperature table, a data table that lets you know what happens for successive amounts of time to the sample, as far as temperature is concerned, as far as the state of the manner and the observation contents of the pot that they're using in that video. So, number 4, list or label the segments of the graph with the following letters. A, where was ice only present? So one of these boxes corresponds to a particular temperature in which ice only was present. And right here, I've got it marked out right there. So A, that's A right there. Now that's a freebie for you. I want you to fill in the rest of them. Where was ice melting? What box would correspond to that particular situation where ice is melting? And there's water and ice. What about when only water was present? There's one of these stations in which only water is present, not water gas, not water solid, but only water. Which one is it? D, when the water was vaporizing. So when it's vaporizing, I'll give you a hint, water is both liquid and gas. Where would that be? And E, when only steam is present. One of these temperatures is a host to only steam. And so at that temperature, only steam can exist. Which one is it? Which one do you say? When you fill that graph in, this depends on how you fill it in. It's not really that hard, but you need to get that right. You need to understand this question. During which segments, A, B, C, D, or E, did the temperature stay the same? You can look at this graph, and there are 2 areas where temperature stays the same. Which are they? What's the correct letters for those? Include those letters in this answer box along with the temperatures that those letters represent, because the temperatures are staying the same. So it's not a fluctuation, it's a constant temperature, which constant temperatures are the ones that are staying the same or remaining constant. Okay, number 6. So since the energy was not raising the temperature of the water during these segments, what was it used to do? You know what's happening, or you should know at least. You should have a good idea what's happening at those temperatures, especially for water. So, number 6, since the energy is not raising the temperature during those points, what is it doing? What is that energy doing? It's an important thing to note that energy is being supplied to this system constantly. There's never a time when energy is turned off and everything's left stand still. No, the energy is continually being supplied from 0 minutes to 10 minutes, as far as we know in this graph. So make sure you understand that. Make sure you come up with a good idea of what's going on when the temperatures are staying the same. Number 7, why did the temperature increase during 3 to 7 minute segment? So right here, 3 to 7 minutes, the temperature increased. Why did it do that instead of stay constant? Number 8, what type of process were these changes, these phase changes, were they endothermic or exothermic? Endothermic is absorption of heat energy. Exothermic is release of heat energy. So if I've got a match and I strike a match, it is exothermic. It gives off a lot of energy. What type of processes were these? Now, I'll give you another hint. They are both the same. Melting and vaporization, or melting and boiling, are both either endothermic or exothermic. Which one is the correct answer? That's all you need to put. Number 9, the final question. Make a general statement about what happens to the temperature of a substance during phase change. We want you to talk about, now let me go back up to the rubric at the top here. I want you to, general statement should include a sentence about temperature values and a sentence about energy flow. I want you to understand that energy flow is different than temperature values. As you can see in this graph, the temperature values are staying the same. The energy level is rising. So make a statement as to why you think that could be. What about phase change is so special that temperatures stay the same? And it doesn't matter whether you're going from gas up here to liquid down here, from liquid down here to gas up here, the phase change always occurs at this temperature for water, 100 degrees Celsius. So let me know what you think the relationship is. What about this system is keeping the temperature constant when the phase is changing? So make a general statement about what happens to the temperature of a substance during a phase change. So I hope that those are good enough clues. I hope that you guys have enough information to be able to handle this lab. And if not, if you're still having trouble, please email me first or call me. My extension is 2518. I'll be glad to help you out. Thank you, and I hope you do well.